Hi everyone, this is Miss Graham, and today we're going to be looking at lesson 25.4, and we're going to look at the first half of this lesson and then finish the rest of it out tomorrow. So go ahead and open up to page 363. We're going to start off going into the margin on page 363, and I want you to go ahead and write down these two warm-up problems below. Draw the picture as well so we can review what you remember about central angles and the arcs that intersect them. Pause the video, work out these two problems, and then resume play when you're ready to go over them. Let's start off with our first problem. We can see that we are working with a central angle measure where they give us it's 4x plus 1. And we can see that it intercepts this arc, which is 97 degrees. So we know whenever we have a central angle, that will be equal to the measure of the arc it intercepts. So we can write 4x plus 1 equals 97. When solving for this, we know we're going to subtract 1 from both sides. So we have 4x equals 96. And then our last step is to divide by 4 to isolate x. Whenever we do that, we should get x as 24. For our second warm-up problem, again, we are looking at central angles. So we know this central angle measure is 60 degrees, but think about how we know the measure of this arc outside of here, that major arc. The only arc that is also 60 degrees is the one where we're not really given an expression for. So keep in mind, if we wanted to solve for x, we would have to do 360 and subtract out that 60 degrees. So we could see how much is left. We're working with 300 degrees, which is the green highlighted part of the arc. So I know if I now set 10x equal to that 300 and then divide by 10 on both sides, x will actually equal 30. Pause the video here if you need more time to correct your work. Otherwise, we're going to continue on today's lesson. Before building off of 25.4, there is one part that I want to go back to into 25.2's notes. So turn back to page 357, and I want you to go ahead and write this visual in our margin. You can see right now that we have a circle, and inscribed inside our circle, we have this quadrilateral. The quadrilateral does not have to have all four sides equal to each other. They can be different in length, but I want you to go ahead and draw this, as well as label each of the interior angles, 1, 2, 3, 4, inside the quadrilateral. When drawing this picture, something that we're going to realize and see is that the angles that are opposite from each other will actually be supplementary. So, in the way that I drew this picture, if I add angle 1 and angle 3, if I add those measures, it'll equal 180 degrees. And if I add angle 2 and angle 4, that will also equal 180 degrees. Once you have the picture, go ahead and we're going to practice working with one problem like this in section 25.2. We're going to look at problem number 17. Problem 17 says refer to circle O below, where ABCD is inscribed inside the circle. AC is actually a diameter, and the measure of angle DAB is 122 degrees. Let's go ahead and label some of this information in our picture. So if we have the measure of angle DAB, that's 122 degrees. And we know if we take the angle opposite from it, really across angle C, we know both of those all together will add to 180. So let's say we put the measure of angle BCD as x, then we know we can take 122, add it to x, and set it equal to 180. So really in this case, we are subtracting 122 from 180. So that way, when we look at the measure of x, or the measure of angle BCD, it's going to be 58 degrees. So we can answer that for part A. Now let's move on to part B. We are actually going to skip part C, so you can cross that out. So for part B, it's now asking what are the measures of the other two angles, ADC and ABC. Now it asks us to kind of explain our reasoning too. Let's think back to what we were originally given in our problem. We were given AC is a diameter. So let's draw that line. Let's connect AC and think about how that's a diameter. Wouldn't it make sense that it lines up with this portion of the arc? Or it could line up with the other portion of our arc. We know those are going to be half of 360. So those are 180. So those arc measures are going to be 180 for each of them. Now think about this. Those two angle measures that we were looking at, they actually open up to those arcs. So if we look at the measure of angle ADC, that opens up to arc ABC. If we look at angle ABC, it actually opens up to arc ADC. So we know those measures are going to be half of 180. So when we're taking half of 180, we know each of those are going to be 90-degree angles. So we can go ahead and add that each of them are 90-degree angles, since we know that those angles open up to an arc that's a semicircle. Let's go ahead and jump now to problems 20 through 22. I want you to see if you can show what you learned and showcased in understanding quadrilaterals inscribed within a circle and answer each of these three problems. Go ahead and pause the video and play it whenever you're ready to answer go over each of the answers. All right, let's go over these three questions. So for number 20, which angle is a right angle? Should be angle ADB because it opens up to a semicircle. For 21, it says, what is the sum of the measure of angle DAB and the measure of DCB? Well, we know that opposite angles in an inscribed quad are going to be supplementary, so we know that they're going to add to 180. Last but not least, it says identify the angle with a measure of 40 degrees. That's going to be angle DAB, since angle DAB and DCB add to 180, and we know angle DCB is 140. So remember, the big idea that we got out of this is that if we know a quadrilateral is inscribed in a circle, then we know the opposite angles will be supplementary. Now that we introduced quadrilaterals inscribed inside a circle, let's jump back to section 25.4 on page 363. We're going to look at half of this section of notes today. So for our learning targets over the next 2 days, we're going to describe relationships among the angles formed by tangents to a circle or secants to a circle. And we're going to use angles formed by tangents and secants to solve problems. Building off the spotlight problem that we did before, Chris realized that he could illuminate the pool with fewer spotlights by placing the spotlights outside the pool and pointing them towards the center. So let's take a look at this visual and see what we recognize. Think about this point outside of the circle of A. It is extended that line to reach points M and P. So isn't that kind of a secant line that we recognize? Same thing for our lower line too. A and Q, all those points are connected, and it goes through the circle twice. It pierces and exits the circle. So that is also a secant line. So question number 1 says, if point A represents the light source, which part of the pool's edge will be illuminated and which part will not be illuminated? So I'm going to use yellow to represent the part that is illuminated, and what part I'm going to put in black shading for which is not. So we can see with the light shining here, we can see that arc PQ will be illuminated. And since it is a minor arc, we only need to use 2 letters to label it. So we're going to say arc PQ is illuminated. And really the rest of the circle all around here is not. Now keep in mind when we're trying to label this major arc, since it covers more than half the circle, we want to use 3 letters. So we want to start off either using P or Q, and we have to end with P or Q, but you can use either M or N. So I could say PMQ, or I could say PNQ. I could also say QNP or QMP. We just have to make sure we go from point P to point Q at some points. So I'll just stick with the first one I said. Let's have PMQ, that arc, we're going to say is not illuminated. Let's go on to question number 2. It says, Chris places the spotlight as close to the pool as possible, while at the same time illuminating the largest possible part of the pool's edge. In the figure to our right, point A again represents the light source and point C represents the center of the pool. So think of how this picture is a little bit different from the last one. This time we don't have 2 secant lines going through the circle. We have 2 tangent lines. Those tangent lines touch at point P and point Q and don't go through the circle. So that's why they're tangent. So maybe as a reminder, let's go through some of this vocab. Let's look at CP and CQ. Remind me of what that vocab is called again. That's right, both of those are radii. Remember, that means when we have more than one radius in our circle, and our radius goes from the center of our circle to the edge. Now let's look at AP and AQ. Again, I kind of gave you a little bit of hint with that. Those are tangents or tangent lines. Now, let's remind ourselves, whenever we have a tangent line intersecting our radius, we know point P as well as point Q, those are points of tangency. So think about what is the relationship when we have a tangent line drawn to a radius. That's right. It creates a 90-degree angle. It's a perpendicular relationship. So we know the measure of angle APC and AQC are going to be 90 degrees. So go ahead and add those symbols onto your picture as well. Now, let's recall from yesterday that our light sources, this angle measure right here, let's do that in pen. There we go. That is going to be 60 degrees. That's what it's telling us right there. It now wants us to find the measure of angle C right there. So we have to consider the angles in the quadrilateral APCQ. So think about all angles in a quadrilateral have to add up to 360, even if it's not inscribed fully in the circle. So we already know that each of these is 90. We already given our 60 degrees. So let's say we add 90 plus the 60 degrees. And we want to subtract that from 360. Well, that'll give us our answer for the measure of angle C. When we add all of those together, we are going to end up getting 240. And then when I do 360 minus 240, lo and behold, I get 120 degrees. So the measure of angle C here is 120 degrees. Now, a similar problem from last time is coming up again. We're looking at what fraction of the pool's edge will be illuminated by the spotlight and what fraction will not be illuminated. So let's highlight the part that will be illuminated. All of this right there will be illuminated. So we have to think about how this arc right here, it's intercepted by the central angle of 120 degrees. So we know that arc is 120. So to find out the rest that is illuminated, we'd have to do 360 minus 120 to at least figure out what that degrees is. So the part that's illuminated is 240 degrees. Now we have to take that 240 degrees and we have to figure out what fraction of the pool is illuminated. So we take that over 360. When we divide that out, we see we have 2/3 of the pool is lit. So of the pool is lit. And then it asked us to build off of this. What fraction of the pool will not be illuminated? Well, that means 1/3 will not be illuminated. All right, let's move on to question number 3. So question 3 says, in our diagram below, point C represents our center of our circle. We have AP and AQ, they are tangent to the circle. So it says if the measure of angle A is x, so let's add that into here. So the measure of angle A is x. Then we want to find an expression for the measure of arc PQ. So we want to find a measure for that arc. I want you to think about this a little bit. Think about what we just did in our last problem, question number 2. Think about maybe specifically part D and how we can connect those two pieces together. Once you've written something down, go ahead and resume playing of the video. Well, remember, we have this measure of angle PCQ. It intercepts arc PQ, and it's a central angle. So we know that those will be the exact same measure. Now remember, since we have opposite angles, those add to 180 degrees. So in order to find the measure of arc PQ, we really have to take 180 degrees and just subtract out x, which is the angle measure for A. I know, that's it. I know we're keeping the homework light this week, so if you look at page 364, you are going to complete question number 4. There are 4 parts to it, and it will build off of what we just learned about tangent lines and the angle measures as well as the arc measures within our circle. All right, good luck and happy mathing.